Welcome, everyone, to Topic Wonders number 17. I am your host, Matrix Lord 212, and I'm with Steampunk Star Raisin.
Here in Hollywood of AmberStreet.com.
All right, so what science-y stuff do you got for us?
Three newly discovered Earth-sized planets may be primed to spot, are a prime spot to hunt alien life. Sorry, I mixed that up a little bit. Yeah, the Kepler telescope. There's a spacecraft that's orbiting the sun, where it's peering deep into the Milky Way galaxy, and it's discovered thousands of planets. And the prime interest is discovering planets that are the most Earth-like. In other words, planets that are in the Goldilocks zone. The Goldilocks zone is an area in a solar system that's not too hot, not too cold. The outer edges of our Goldilocks zone would be the planet Venus. Venus is slightly too hot. Mars is slightly too cold. But if you have planets in between that area, they've got a calculation for it. I'm not a scientist, but they got a certain calculation for it where they can theorize that it is highly probable that if a planet's in the Goldilocks zone and it's not too large and it's not a gas giant, then it has an increased chance of a probability for life. And according to this article, that's what they've discovered: 3 more Earth-sized planets. The problem with hunting for alien life, though, is unless they build something like a Dyson sphere, and you've already done a topic wonder on that, and we've already talked about that in a previous episode. But unless aliens build like super massive technology like a Dyson sphere, it's going to be almost impossible to hunt for them. And unless we develop interstellar spacecraft. So I think discovering other Earth-like planets, that should be the motivation to develop interstellar spacecraft. We just got to be willing to invest the energy and money. And also, hunting for alien life by using radio signals is nice, but I remember there's times when they're trying to communicate with like the rovers on the surface of Mars, and they'll lose communication for a day, and then they'll reestablish communication. So if you have trouble with cosmic interference, because there's a lot of radio waves in deep space from different stars emit radio waves, and so do quasars and many other cosmic objects. There's a lot of interference, and you're having a hard enough time just communicating with a rover on the surface of Mars. It's going to be very hard to find an alien signal, because by the time that alien signal, say they're 50 light years away, by the time that alien signal even got here, it would be so weak to be almost undetectable, and there would be so much interference that you may get an alien signal and not even realize you got it, because you'll hear mostly static.
Right.
So we need to develop interstellar spacecraft. Recycling nuclear weapons. I mean, they talked about this in the 50s. Recycling nuclear weapons, using nuclear propulsion. You could possibly go up to 20% the speed of light, and that would make it humanly possible to explore the Alpha Centauri solar system, which they originally thought that Alpha Centauri didn't have planets. I'd have to look it up, but they realize now, especially with the Kepler spacecraft, that it does have planets, and it's a binary star system. So how cool would that be to go to a binary star system and see if there's any life in that solar system, and how the binary stars may have affected that and maybe change things up. We could learn so much.
Right.
We could learn so much.
Now, why don't you explain to people what a binary star system is?
Well, binary meaning 2, it comes from Latin.
Okay.
It's 2 stars. Our solar system was almost binary star system. Jupiter resembles a brown dwarf. Jupiter is very similar to a brown dwarf, because I don't know if you know this, Jupiter emits its own radiation and its own heat energy, but it's not massive enough to ignite into a star. It's a little bit too small to be a star, and that's the reason why, if you look at Jupiter, Jupiter almost resembles another mini solar system. You've got moons that are bigger than Mercury,
moons could be considered planets, basically.
Yeah, I mean, some of the moons of Jupiter and the moons of Saturn's the same way, because Saturn's also a gas giant. The moons of Jupiter and Saturn, if you were to take some of those moons and put them in their own orbit, then they would be classified as planets, because they're bigger than the planet Mercury. They're bigger than Pluto, bigger than the dwarf planet Ceres. But yeah, I mean, Mercury is large enough to be considered a planet within its own right, and you've got moons like Europa that are bigger than Mercury and bigger. I know Titan is one of the more fascinating ones because that's one of the few moons that they actually sent unmanned spacecraft to the surface to take pictures. But Titan is actually larger than our moon and larger than Mercury.
Wow.
So, I mean, if Titan was in its own orbit around the sun, that's one of the definitions, one of the new definitions for a planet. It has to clear its own orbit. And a dwarf planet, if it can't clear its own orbit, if it's sharing its orbit, its elliptical orbit with, I'm making a motion like an elliptical orbit, if it's sharing its elliptical orbit with other cosmic objects, then it technically doesn't meet the definition of a planet. It would be considered an asteroid and a dwarf planet. Because like Ceres is very interesting because people get confused with Ceres. You can say that Ceres has been promoted. It's a cosmic object, or it's a planetoid object between Jupiter and Mars. And it's smaller than our moon, and it's smaller than Mercury. It's about, I think, 600 miles in diameter. Mm-hmm. There's a possibility that it might have an ice crust, and there might be a liquid ocean beneath the surface, and it could have life. But Ceres is round. It's large enough object that its gravitational mass it's collapsed in on itself in an even way, and it's a round ball, and it looks like a planet. And
right.
It's by definition it's an asteroid, it's a planetoid, and a dwarf planet all at once. You can be an asteroid. A cosmic object can be an asteroid and a dwarf planet at the same time. It meets both those definitions.
What about that planet Sedna?
That's a dwarf planet.
Okay.
Sedna is bigger than Pluto.
And what about Quasar or something like that? I think it was
Quasar. I think some of those are hard to. My favorite one is Maka Maka. I like to call it Planet Make Make because it's spelt like Make Make, but it's
right.
Hawaiian god Maka Maka. I need to look up what Maka Maka did in Hawaiian mythology, but yeah, Quasar, Sedna. Quasar, I think, is slightly smaller than Pluto, but it's still almost as big.
Right.
And Sedna is bigger, and Maka Maka, I think, is slightly bigger. And Maka Maka is red. It's the second reddest planetoid, because like Earth is a planetoid object.
Right.
Everything's a planetoid object, but it can be something else. That's the confusion with the new definition of planet.
Right. I mean, Pluto is no longer a planet, right? It will never be a planet.
No. I mean, Pluto is a planetoid object and a dwarf planet, but it's not a full planet. It's not a full-size.
And it will never be reclassified as.
Well, I mean, if they want to reclassify it, they could. There's a committee of astronomers and scientists, the astrological. I can't remember the name of the committee right off.
Right.
But there's a scientific committee that meets because they're discovering new asteroids, and somebody has to name them. There's an asteroid named after James Randi. I think it's like Randi 001 or something like that.
Right.
They name objects. They're a naming convention, and they also changed the definition of planetoid objects, which is fine, because that's the thing about science. As we learn new things, we can change our perception of reality, because we are like, oh, we didn't notice this before.
Right.
And I know Arizona passed a law, which is to me a waste of legislation. You'd be doing other better things. They passed a law where they still classify Pluto as a planet. I mean, Pluto does have a lot of active geology that would be that you could say, you can make an argument that it's a planet, but then, and I know that's your opinion, but then if you're going to call Pluto a planet, then you're going to have to say that Sedna is a planet.
That's fine.
Ceres is a planet.
Here's the thing, right? I'm not one that has to be a certain amount in the solar system. I mean, if there are planets in the solar system, there are planets in the solar system. I mean, I really don't understand how, after all these years, they always said since the 70s about Planet X, because we used to have 9 planets, and there was a 10th planet that they couldn't uncover, and this thing keeps coming up over and over again that there's another planet in the solar system that they can't see. What the hell planet is that?
Well, that's an interesting one because they actually have a
And we've lost Steampunk Star Raisin.
influenced by a large, massive object that gives internet connect. Oh, sorry.
Yeah,
Hear me now?
Yeah.
My internet connection's a little bit unstable here. There's a lot of people here at this Starbucks in Hollywood. There's some gravitational pull. There's some gravitational influence of smaller cosmic objects out there, in the solar system that shows circumstantial evidence for a planet X, but they haven't been able to prove it because they can't see it. They haven't been able to. They've been scouring the skies. It would be a very dark and faint object. They think that it's probably about the size of Neptune. So it might even be like a gas giant, but way out there. And if
how many planets do we have, though? Like, I mean, dwarf planets, and how many more are there in the solar system? Like,
well, I haven't calculated dwarf planets because they keep discovering more. But the New Horizons is going to go out into the Kuiper Belt and explore more. But I think it's between like 20 and 30. If you're going to planetoid objects that orbit the solar system, but technically moons are planetoid objects too.
Right.
So, you can be a planetoid object, but you can be a dwarf planet, and you can be an asteroid at the same time. I mean, like Ceres is an asteroid; it's a planetoid object, and it's a dwarf planet. But Pluto is not an asteroid, but it's a dwarf planet.
But the planets that are beyond Pluto in the Kuiper Belt, right?
It's fair to call them planets because they're still dwarf planets.
Right. I mean, where are they? So they would never be able to support life because they're so far from the sun, correct?
They're low energy planets. They're not getting much solar energy from the sun, maybe like less than 1%.
But couldn't there be radiation or something in the Kuiper Belt that could mimic the energy of a sun to make life?
There's a lot of comets out there, and a lot of the dwarf planets probably resemble comets. They're just very large comets.
So there could be a whole, like, here's the thing: is there an area where there's tons of comets that just go through?
Yeah, that's the Kuiper Belt.
Right. So that could basically be enough energy to sustain life from the energy of a comet instead of a sun.
I mean, it would not be life like we know it. It could be life of a different configuration.
Could it be life that it has life, and then when there's no comets around, it's like a hibernation, and then when they're around again, it's like they're awakening again?
I remember what Carl Sagan said on this. Sorry, I bumped my table. I remember what Carl Sagan said on this subject because Carl Sagan, and I read his book Dragons of Eden, which was great because he talked about a lot about biology. But Carl Sagan had a degree in biology and astronomy. He was an astrobiologist. He worked for NASA. And his job was to theorize what life would be like in different environments. And he had a very hard job because the only life he had to compare to was just Earth. Mm-hmm. And he was talking about like possible life on Jupiter, but the configuration of that life would be totally different than what we considered life. And he was talking about aliens that looked like balloons filled with gas. And as they ate, they would climb higher in altitude. And if it got too high in altitude, they would explode. And then their biological material would be recycled, and they would be like air creatures. And if such life, and we never found life like that on Jupiter.
Well, what's the air creatures in the Earth that they have taken pictures and they tell the photographers to remove those pictures from they have from like worm like?
That's just conspiracy theory with motion blur.
Okay.
That's bugs. People taking pictures of bugs, and it's a blurry picture of a bug. I mean, I'm familiar with that, but I like to stick to the scientific method. You can say, yeah, it's possible that there's some invisible creature that we can't see, but show me tangible evidence than motion blur. Somebody takes a picture of motion blur, and they claim that they see, a devil with hooves. But that's just motion blur to me,
Right. This has been a very educational episode, Steampunk.
Well, I
really know your astronomy, yeah.
I really love astronomy, and Carl Sagan was a big influence on me because I missed the man. He had a way of talking about astronomy in common language that everybody could understand and making it interesting.
Passionate about it, yeah.
Yeah, and I'm very passionate about astronomy and space exploration. I would think that that's the most important thing that man can do would be to develop interstellar spacecraft because within a billion years, Earth is going to become unlivable, not because we're going to destroy the environment, but because the sun will eventually start to heat up and
Right.
it'll be too hot to live here. And so, I mean, I know that sounds like a lot of time, a billion years, but if you're trying to develop interstellar spacecraft, you're probably going to need millions of years to perfect that to be able to explore the entire galaxy and not even the entire universe. And we need to start thinking about the future. And
Yes.
I think that I mean, even just getting, let's build the cheapest kind of interstellar spacecraft you could build. I think would be nuclear propulsion. Build something like that, recycling old nuclear weapons. It'd be a positive way of using nuclear weapons, and you could reach about 20% the speed of light in theory. They'd have to test it, of course. And I would love to go to Alpha Centauri. That would be so. Even if there was no livable planet in the Alpha Centauri system, I would just love to be in another solar system and see what it would be like. But I don't think it's going to happen within my lifetime. It doesn't seem to be much pro science anymore.
You never know, bro. All right. On that note, that's it for this episode of Topic Wonders. We're going to have a future episode where we're going to really go deep into naming all the planets that we have knowledge of in our solar system, dwarf planets, everything. So that's going to be a big episode that, you're going to have to help me with, Steampunk.
Yeah, I'll have to do some research. I don't know how many dwarf planets there are, but there are a lot.
All right. On that note, thank you, Steampunk.
All right, well, thank you.
Take care. Bye for now.